everyone. Well, welcome back. I wanted to get back with you on three other kinds of movement of materials across the cell. The last time we looked at diffusion and osmosis, and we spent a little bit of time on facilitated diffusion as well. Those kinds of movements across the cell membrane were when materials were always going from a high concentration to a low concentration, and that's what materials normally do. But what about when a particular molecule is needed in high concentrations inside the cell, and yet it's only available outside the cell in few numbers like you see pictured here? Well, that's when energy is going to be needed. And so there's times when energy is used to transport materials not down the concentration gradient, but up the concentration gradient as they move across the membrane. So that's what we want to focus on today. And there's three different ways that this occurs. The first one we just refer to as active transport, where energy is used typically in the form of ATP, adenosine triphosphate, and there are proteins that are available on the cell membrane that move a substance against its concentration gradient. In other words, not from high to low, but from low to high. All right, and we're going to be using this particular molecule known as ATP. Typically, molecules do not go from a low to a high concentration, and so energy is going to be needed. This transport protein is going to change shape as a result of ATP being plugged in. You don't see it pictured here, but it's going to plug into this transport protein, change its shape, and physically carry across those needed materials that the cell needs in higher concentrations. We sometimes refer to this as a pump, and you're going to see that referred to, for example, on the Keystone exams in Pennsylvania as a pump. So be aware of that. So when you're seeing that term pump, we're referring to the use of ATP, we're referring to active transport, we're referring to going from a low to a high concentration, as you see pictured here. And then there's other instances that we want to consider where a large material, a large object is going to be brought over into the cell. In this case, we're looking at endocytosis. Endo, as you know, means inside of the cell, where something such as a bacteria needs to be attacked by a white blood cell, and it's going to be destroyed inside that white blood cell. Well, it's got to get in there in the first place. And here you can see the cell membrane is actually going to unfold itself around that material and then be brought into the cell, into a vesicle where enzymes are injected, and whatever that is going to be broken down, denatured inside the cell by those enzymes, and completely dismantled. We refer to this particular type of process as phagocytosis, where a pathogen, for example, is taken inside the cell. And exocytosis is just the opposite of that, where there are materials that have been stored in a vesicle, and they're going to be removed, expelled from the cell environment through the cell membrane, where that vesicle is going to join to the cell membrane, and it's going to be released outside of the cell. All right, great. Thanks for watching. Bye-bye.